So today I'm actually going to take you through the workbook, and we're going to look at page 29. Alright, I'm just going to read so you can open your the workbook and then read with me. So page 29, our regular workbook that we use in class. And reminding yourself that what we did yesterday was the fourth and last chemical reaction you need to know. It is called decomposition reactions. Alright, I'm reading from page 29. It says, when a compound undergoes a decomposition reaction, usually it breaks down into its component elements or simpler compounds. So it basically just breaks down to something simpler. So there are three ways we can do this. Thermal decomposition, which is when you use heat, catalytic decomposition, which is when you use a catalyst, and electronic decomposition or electrolysis, when we use electricity to decompose a compound. In this standard, we only study thermal and catalytic decomposition. Alright? Now, thermal decomposition reactions, as the name suggests, involve breaking down chemical substances into simpler substances using strong heat. So we're going to focus now of these two that you need to study, thermal and catalytic. I'm going to start with thermal decomposition, and we're going to see how that involves breaking down of chemical substances into simpler substances using strong heat. So I'm going to go through this experiment, but what I've done is I've changed calcium carbonate to copper carbonate, because yesterday that was the fine green powder that I had used when I demonstrated this for you. So I will read this for you. It says, place a pinch of copper carbonate. So you do the same thing that I've done in the book. You strike out calcium and you write copper there. So copper carbonate powder into a dry Pyrex test tube, which is that boiling tube. Then we had lime water in a separate test tube or a beaker, and we can either hold it like it is shown in this diagram, or we could use what they've said right at the bottom here, which is the delivery tubing. That's the tube that I used to allow the gas that is formed to pass into the lime water. They're asking us to observe the compound heated as well as the surface of the lime water, then shake the lime water. Use your observations to work out the products of the reaction. Alright, so the first question here says, name the products that are formed. So take a minute and you write down what the name of the products are. So we did this in our exercise books yesterday. Copper carbonate on heating breaks down to form copper oxide and carbon dioxide. Okay, so those are the two products that are formed. So you write this along with me as I go through the video. Now you can also ask the teacher to pause the video if you need to. Then the next part of it says, describe the observation. Alright, so they want you to talk about what you saw. What we saw was that copper carbonate is a fine green powder, right? But when you heated it, it actually changed the color. What did it turn to? It turned to a black powder. And that black powder indicates that copper oxide was being formed, because it's that compound that is actually black. Alright, so my answer that I've written, and you can do the same thing, is copper carbonate is a fine green powder. On heating, it turned black, indicating that copper oxide had formed. Alright, the next question says, explain what happens to the carbonate ions in the decomposition reaction. So what actually happened to the carbonate ion when it was heated strongly? So the carbonate ion is CO3 2-, that is our carbonate ion, and when you heat it strongly, it actually breaks down to carbon dioxide, which is CO2, and what are you left with? One oxygen and this charge, which is 2 minus. So this is our carbon dioxide, and this is the oxide ion, which then gets attracted by the copper ion. So you have the copper ion, which is a positive ion, and these two ions attract each other and they form copper oxide. But carbonate ion on its own, actually on heating, forms carbon dioxide and the oxide ion. So that's the answer to that question, question 3. Okay, and then they've asked for, in question 4, they're asking you for the word equation. Now we did this in class, so I'm not going to do, you could copy it from your exercise book. What happened when you heated the solid and what happened when you had the reaction with lime water. Alright, so we got those two things were done in class, so you can copy it from your exercise book. And also writing the symbol equations for the reactions, which is copper oxide reacting with carbon dioxide, copper carbonate breaking down to copper oxide and carbon dioxide. I'm giving the symbol. And then the lime water is calcium hydroxide reacting with carbon dioxide to form calcium carbonate and water. So take a few minutes, you can pause the video and just copy this from your notebooks that you had written in yesterday. All right, so the next part, I want you to close this book for a bit and then just go to your exercise books and open to a new page, and then we'll start writing in our exercise books. All right, so today's date is the 23rd of July. All right, and so what I want to actually do in this part of the lesson is look at 3 types of thermal decomposition. Okay, 3 types of thermal decomposition. The first one is we're going to look at what happens when you heat a metal hydroxide. So metal hydroxide, when it is heated strongly, breaks down to 2 simpler compounds. One is a metal oxide and the other one is water. All right, so that's the first type of thermal decomposition. The second one we're going to look at is a metal carbonate. A metal carbonate, on being heated strongly, will give you a metal oxide again, plus what's the other product that was formed? We did it just now. It was carbon dioxide. Alright, so metal carbonate, when you heat it strongly, breaks down to form a metal oxide and it gives you carbon dioxide. And then the third one is a metal hydrogen carbonate. So metal hydrogen carbonate. And hydrogen carbonate is an ion. You may have seen this in the ion table. It's actually got a formula of HCO3 minus. And if you go and look up your ion table, you'll actually see it there. So it's not a new, we haven't really used it much this year, but it is something that you have seen in the ion table previously. So a metal and hydrogen carbonate, when you take them and you heat them, you heat up this metal hydrogen carbonate, it breaks down to give you a metal carbonate this time, plus it also gives you water and carbon dioxide. Okay, so you got metal carbonate, you got water, and you got carbon dioxide. Okay. So copy this. You can ask the teacher to pause this if you like, and then you can copy it into your exercise books. I'm going to now then move on to give you some examples. Alright? So a metal oxide, let's choose metal oxide, let's say zinc hydroxide, metal hydroxide. So I'll actually start with the word equation. Zinc hydroxide, when it is heated strongly, will form zinc oxide and water. Because that's what we wrote on top, right? A metal hydroxide decomposes to give you metal oxide and water. So you got zinc hydroxide, which is ZnOH twice, which is a solid. And then on heating strongly will give me zinc oxide, which is ZnO, and water. ZnO is a solid and water is a liquid. Alright? It's a balanced equation, so we don't need to do anything more. The second one, I'm going to look at a metal carbonate, this one that we had up there. Metal carbonate, we've already got one with copper, so let's use calcium this time. Calcium carbonate, on being heated strongly, will form calcium oxide and carbon dioxide. Okay, so calcium carbonate, the formula is CaCO3, that's a solid. On heating, this forms CaO, which is also a solid, plus carbon dioxide, which is a gas. Alright, so again it's a balanced equation. I don't need to do anything. I've given all the states, and we've got an example for a metal carbonate decomposing. Alright, and the third and final one is a metal hydrogen carbonate. So I'm actually going to give you an example of a metal. I'm choosing sodium hydrogen carbonate. Now, this is a very commonly used chemical, and if you have ever done some baking or you've been in the technology room, you would have used sodium hydrogen carbonate, because this is also known as baking soda. Okay, so the metal hydrogen carbonate on heating, remember our equations right up at the top, it says it's going to break down to give us the metal carbonate, so that will be sodium carbonate plus water plus carbon dioxide. So you get three products this time. Alright, so let's write the symbol, the formula for this. Sodium hydrogen carbonate. Sodium is Na plus, and this hydrogen carbonate is one ion, that is HCO3 minus. So its formula is just NaHCO3, and that is a solid. Alright, on heating, that gives us sodium carbonate. Sodium is Na2 plus, carbonate is CO3 2 minus, so together that makes it NaCO3, which is also a solid. Water is H2O, and carbon dioxide, which is CO2, and that's a gas. Water is a liquid. Is this equation balanced? Is probably not, so let's look at if this equation is balanced or not. So I've got one Na on this side, I've got one Na on this side, I've got one hydrogen on this side, but I've got two on this side. I've got one carbon on this side, but I've got two on this side. I've got three oxygens here, but I've got six here. So if I put a 2 in front here, so Na was 1, hydrogen was 1, carbon was 1, and oxygen was 3. Na on this side was 1, hydrogen was 2, carbon was 2, and oxygen was 6. Okay, so if I put a 2 in front here, it makes it 2 hydrogens, 2 carbons, 6 oxygen, but it also increases the number of sodium. But I only have one sodium on this side. Oh, okay, that's because the formula is incorrect. Okay, so that is Na2 plus and not Na2 plus, it is Na plus. Na is plus, and so the formula for sodium carbonate is Na2CO3. Yep, now that's all right. So we've got a 2 there, and you got 2, and that's now balanced. All right. So sorry girls, I'd made a mistake with sodium carbonate. It's Na2CO3, and now it's a balanced equation. All right. So 2 hydrogens, 2 carbon, yeah, and 6 oxygens. Okay. So how this applies to baking is when you add your baking soda to your cake batter. All right. So you got your cake batter here, and you added your baking soda. Now when you pop that in the oven, what happens is that it breaks down to sodium carbonate, which is just, it remains with the cake flour and we eat it, it's fine. Then you form water, and because of the very high temperature in the oven, that's going to be steam, and it also forms carbon dioxide. That means the gas, that carbon dioxide, as it leaves, what it does is, so that's your cake tray, or if you're making bread, the carbon dioxide gas, as it leaves, it stretches the gluten in the flour and it pulls it like that, and that is called the cake rising. So if it was not for this carbon dioxide, you wouldn't have the cake rising, and you wouldn't actually have a cake, you might have a cookie then. Alright, so that's really the chemistry of baking, and it relates back to a metal hydrogen carbonate decomposing to metal carbonate and water and carbon dioxide. Alright, so let's look at our workbook again and see if we can go and actually write down something that so I would want you to work through page 32. So take your exercise books, go to page 32, and then you can complete the word equations. So calcium hydroxide, now that's a metal hydroxide. You know what happens to metal hydroxides on heating. So you do the word equation and the symbol equation for this. Do the same for iron hydroxide, lead hydroxide, and aluminium hydroxide. Alright, so when you've completed that page, I want you to move over to page 33, and I want you to complete this based on what I've just taught you and the stuff that you've written in your exercise books. Alright, so metal hydroxides are converted or are decomposed to form metal oxides and water, and then you give an example. Same for metal carbonate, metal hydrogen carbonate. Alright, so you complete those two. And then you can attempt question 2, because it's got the same example that I gave you just now, just that we're not using it in a cake. You just got your baking soda, which is sodium hydrogen carbonate, heated strongly, and then the gas formed is bubbled through lime water. Now remember that the baking soda is a fine white powder, so that's what it will look like, and on heating it converts to sodium, it breaks down to sodium carbonate, which is also a fine white powder. So that would really be the observation. So try and work your way through that bullet point, and then linking the observation to the relevant chemical species, writing a balanced equation, and saying how this is actually used in the kitchen. Now if you complete all this work, then you can start looking at catalytic decomposition, and you could probably, if you have your laptops, you can start using your laptop to see if you can find some information on this. But otherwise I will continue with the lesson on Friday.